Welcome to this video where we are going to dive into take care of each character from left and right to make the string, in fact, to have the result respecting a given condition. So basically, you receive as input a string like this. You're supposed to take off a couple of elements that you want from left and a couple of elements that you want from the right. And the goal here is that the result array with those elements that you took should contain at least Ka, Kb, and Kc. And for us to achieve that, we need to, like, the solution should be the minimum number of elements that you should take in order for you to have the condition being respected. So let us have like a first look at the thing. If you take all of the elements and you are still not able to have at least Ka, Kb, and Kc, that means there's actually no combination that will help you to have the solution. So to have the -1 is actually straightforward. Now that we have this, how can we shrink our element that we took? So what we can do is that we can say we have like all of the elements that have been taken already. What we can do is that we can use a two-pointer approach and found the longest substring that we can remove until have the condition be respected. What does that mean? If I remove this substring consisting of this first element, I will have a result of 8. I'll have a result of 6, 2, 2, which is actually a valid solution. And this is a valid solution with the length of element that I took less than this one, because this one is actually all the occurrences that I took, which is actually 12. This is actually a size of 10. And then you do agree with me that with the same logic, you can see that this solution, if you take this, you are going to have a 4, 2, 2, which is actually 8. So this is actually the best solution, the best option that you can take to have the left and the right having at least Ka, Kb, and Kc. So now that we have like a kind of overview of the problem, how are we going to manage to have this longest substring? So for us to get this longest substring, we are going to use sliding window. So we are going to have like our left pointer here and our right pointer here. Our right pointer also here. Keep in mind that we have this our map initially. The left pointer is going to add element, whereas the right pointer is going to remove element. That is important. And then what will it look like? Initially, I will have my left at 0. Left is at 0. I'm doing nothing yet. Right is also at 0. I'm going to try, can I remove this and still have my map being valid? If I remove this guy, it's going to be 7 here. So removing this one is not actually a problem. So I will be here. So I'll move my right. Can I remove this? Yes, it's possible. I will be here. Can I remove this? No, I cannot remove this. So this is actually one element that I cannot remove. If I cannot remove this, that means all of the elements from the right till the left are actually elements that I can remove. If I can remove those elements, I will now compute the length that we will give for me to remove all of those elements. And after doing that, I will add the element at the left. And I will try, after adding that element at the left, can I still move right some character in front? In this specific case, it will not be possible. I will again add the element. So adding the element will say, from left now, I will have, initially I added this one. After I'm adding this one. Now, will adding this one will help me to move this one forward? No, I cannot move because if I want to, no, I cannot, because if I'm trying to remove this guy, I'm going to have only one B. So now, the left pointer now is going to be at this position. It's going to add another B. At this time, we have the B that was there before and the B that has been added with the left pointer. Now, can I remove this with the right pointer? Yes, I can remove. So now the pointer, the right pointer is going to come here. The right pointer is going to come here. and I will ask, can I remove this one? Yes, I can remove. It's going to come here. Can I remove this one? Yes. Can I remove this one? Yes. Can I remove this one? Yes. Can I remove this one? No. Since I cannot remove this one, that means I can remove all of the elements from here till here, right? So I can remove all of the elements. So you're not taking this one because this is the one that you cannot remove. So you can remove all of the elements from the left, from the right minus one actually till the left. And in this scenario, this is the length of the element that I can remove. So basically, that is the approach you are going to use in order for you to find the longest substring that you can remove and still have your array respecting the condition of at least k of all of the occurrences. Okay, so now that being said, what would the code look like? So I'll just implement it and I will explain to you again. Let's dive into the code. I will have okay, so this is what we just described. So first of all, you have your map of occurrences. That is what you're doing here. You count the number of occurrences, and then after that you check if in your array of occurrences there is only one element with an occurrence less than k, you return -1 because there's nothing you can do. Now don't forget that at this time you have a scenario where you finally remove all of the elements. That is why the initial answer is actually n. In this scenario, we know there is a solution and that the maximum solution is actually with length of n. Now we are going to try to shrink our solution. Now for us to shrink our solution, what we said is that we are going to try to move right until you find an element that you cannot remove. And an element I cannot remove is an element with a number of occurrence exactly equal to k. So you are going to say, okay, can I remove this right? Is right less than the size because I don't want to be out of range? And is the number of occurrence of that element that I'm trying to remove greater than k? If it's the case, then I can remove it. If I find myself with one element that I cannot remove, that means that is actually I would say a point where I can compute the distance. So I'll just compute the distance here, and after computing the distance, I can move now my left pointer one step forward, and moving the left pointer is actually saying, okay, if you want to consider, if you want to move the left pointer, that means you are adding this one to the element that are not part of the range that we are taking, and then you move your cursor one step forward. That means this one now can be considered as element that has been removed. Okay, so that being said, you will be able to have this, and then you do this while left is less or equal to the size, because you have the left plus here. So if it's already equal to the size, no need to come here because you will not be able to access s of left. So let us submit and see what it gives. So working pretty well. So this was my approach of solving this. I hope you enjoy it. Feel free to give me any input. I'll be really happy to interact with you regarding this. See you tomorrow for a new problem. Ciao.